The chemical trichlorophenol has multiple uses from fungicide to antiseptic and even hexachlorophene creation. Manufacture of this chemical compound involves many deadly chemicals, one of which, dioxin, would plague a small town in Italy. When I was watching one of my newfound favourite comedy shows, I saw a few references to a chemical disaster in Seveso, and this led me down a research wormhole. Seveso is an Italian town in northern Italy, 13 miles north of Milan, and in the mid-70s had a population of around 17,000 people. Ultimately, this population would be the largest to be directly exposed to dioxin. Today I'm going to rate this disaster here on my Plainly Difficult Disaster Scale. ICMESA was a factory located near the town of Meda, a subsidiary of Swiss-owned Hoffmann La Roche. The factory began manufacturing 2,4,5 trichlorophenol from 1971. B department at the Meda plant manufactured TCP, which was subsequently transported to another site to produce herbicides and antiseptics. You might be wondering why the event wasn't called the Meda disaster. Well, the answer is pretty simple, as it was Seveso who got the brunt of the balls up at the plant. Let's have a look at the manufacturing process and how the deadly dioxin chemical got involved. You see, dioxin is a byproduct in the manufacture of trichlorophenol. It is formed by condensation of two molecules of 2,4,5-TCP. The unwanted byproduct is limited due to the temperature needed for the trichlorobenzene and sodium hydroxide reaction to around 160 degrees centigrade. As a disaster would later prove, higher temperatures in excess of 180 degrees centigrade would create more of the unwanted dioxin than the usual minimal amounts. Reactors used on site were equipped with stirrers to mix the ingredients and their solvents, and a condenser used to eliminate the water in the condensate and to feed xylene back into the reaction. Each 10,000 litre reactor was made of chromium nickel molybdenum alloy and were heated with steam and cooled with water. The steam was at a pressure of 12 bar and came from the exhaust from an on-site electricity generation turbine. The temperature of the incoming steam didn't have a thermometer, meaning that the operators could only monitor the overall reactor temperature. A rupture disc leading to a roof vent was provided with a tear pressure of 3.8 bar to protect the reactor from overpressure. The reactors were equipped with a large cooler and had a 3,000 litre reservoir of water ready to flood the contents if needed. One big issue with the setup was that the reactor was not equipped with a temperature alarm and cooling could only be started manually, meaning the system was not fail-safe. This will become apparent later on in our story. For the process, the Meda plant mixed solid sodium hydroxide, 1,2,4,5-TCB, ethylene glycol, and xylene using the reactor's stirrer. The initial reaction mixture was heated at 170 degrees Celsius using steam from the plant's turbine. The mixture was kept at this temperature for around 6 to 8 hours. After this, distillation of the mixture took place between 3 to 4 hours to recover clean solvent for use later on in other work. Once distillation was completed, 3,000 litres of water was added to the reaction medium to bring the temperature down to between 50 to 60 degrees centigrade. The total process usually took between 12 and 14 hours start to finish. The contents of the reactor were then hydrolyzed with an aqueous solution of hydrochloric acid to release the trichlorophenol from sodium trichloropheniate. 10 hours later than usual, on the 9th of July 1976, the 2,4,5-TCP production started at 4 p.m. The plant was to be shut down over the weekend, and because of this the process was interrupted when only 15% of the solvent was distilled. And crucially, the final stage of adding water to reduce the temperature wasn't completed. Around 15 minutes later, the stirrer was shut down, leaving the reactor's contents to settle. The operators signed off at 6 a.m, leaving the reactor unattended. With the stirrer turned off and the mixture being at a low level, the heat coil heated the air above the chemicals, increasing the surface temperature of the still liquid by at least 31 degrees centigrade. The temperature reached 190 degrees centigrade and started an exothermic reaction, raising the pressure in the reactor. With no one monitoring the reactor and no automatic cooling system, the exothermic reaction turned into an uncontrolled runaway. Eventually, the expected would happen and the reactor pressure went past that of the 3.8 bar rupture disk. Upon surpassing the pressure, the disk ruptured, releasing a reddish cloud up to the chimney of the process building, spreading its contaminants over the local area. An estimate of between 0.2 and 2 kilograms of dioxin was released into the atmosphere, which would eventually come down on the population below. The plume rose to a few meters above the ground and was spread southwest by the blowing wind. Luckily, one of the plant supervisors was near the plant and rushed to shut the reactor down. The event went unnoticed until a day later, when some children who had presumably been playing in their gardens started to show signs of intestinal problems and high fever. Vegetables and crops looked burnt and several animals were affected. The ICMESA informed local authorities that a herbicide cloud likely to damage crops had been accidentally released. 2 days after the release, locals were told not to consume any products from their gardens, but things would get worse. 4 days post-exposure, children in the area exhibited burns to the skin and local pets and animals started to die. Over the next few days, several children were hospitalised. However, the doctors, not knowing the cause, were hindered in treatment. Until 10 days post-exposure, the plant managers admitted to dioxin being present. After almost 2 weeks of exposure to the local residents, it was decided to evacuate the area affected by the plume of the deadly dioxin. 11 towns were impacted and the areas were split into 3 zones. Zone A covered 110 hectares, including Meda and Seveso, and dioxin concentrations greater than 50 micrograms per square metre. 736 residents of this zone were evacuated by the end of July. Zone B covered 270 hectares, including Cesano, Maderno, and Deserio, had dioxin concentrations between 5 and 50 micrograms per metre squared. In August, all pregnant women and children under 12 had to leave the area during the daytime to reduce exposure. All agricultural activities were also prohibited. Zone R, or Compliance or Caution Zone, consisted of 1,400 hectares where dioxin was detected in trace quantities, and farming was restricted. Around 2,000 hectares of soil was contaminated, and over 80,000 animals died either directly or due to the liquidation works. Short-term effects on the human population was primarily burns. However, long-term effects were chloracne, cancers, respiratory issues, and diabetes. As a side note, chloracne is a pretty nasty condition as it causes an acne-like symptoms on the skin, usually around the face, neck, and armpits. The condition is particularly resilient to treatment and can persist to up to 2 years if you're lucky, or unlucky, lifetime. Not only the physical effects of the disaster were seen in the local population, but also the psychological toll. Adding into this was the economic damages to the area. All activities were prohibited in Zone A, a decision affecting 2 industrial companies, 37 cottage industries, 61 farms, and 4,000 kitchen gardens, all of which would have to be abandoned. The clean-up efforts in the region would take 5 years. All of the contaminated soil, construction waste, and animal dead bodies were buried in Zone A in 2 sealed containers. In total, 200,000 cubic metres of material was removed and buried. In July 1977, over 500 residents of Zone A were allowed to return home, and Zone R was allowed to resume agricultural operations. The ICMESA plant was demolished in 1982, and waste materials were put in barrels designed for radioactive waste for incineration in Switzerland. Anything of value was removed for decontamination and later reuse. All remaining waste was buried in a container on site. The land would later be reused, eventually turning it into a local sports centre. Zone A and Zone B were declared cleaned up, allowing construction in 1984, essentially calling the end to remediation works. 1983 saw the legal ramifications from the disaster. Senior management of ICMESA was given a suspended sentence of 2.5 to 5 years. The disaster's cause was down to, quite obviously, operator negligence, as the reactor was left unattended mid-cycle. Even though this was the case, knowledge on the formation of dioxin was somewhat limited, as such a disaster was thought not to be possible. You see, in the 1970s, scientific literature said that decomposition of the reaction mixture was 230 degrees centigrade. But the literature was proving to be out of date, as multiple dioxin forming incidents had happened in the early 1970s. The critical temperature proved to be closer to 180 degrees centigrade for a weak exothermic reaction, leading to a more serious runaway reaction. Hope you enjoyed the video. If you'd like to support the channel financially, you can on Patreon from $1 per creation, and that gets you early access to videos and access to votes on future videos. I have YouTube membership as well from 99p per month, and that gets you early access to videos as well. Check me out on Twitter, and if you want to wear my merch, you can purchase it at my Teespring store. And all that's left to say is thank you for watching.